I think that most people along their 3D printing journey have the thought that, hey, maybe I should start making some money off this thing. So let's take a look at how much money it takes to produce one of these parts, and then how many of these you would have to sell in order to pay off your 3D printer. This part is just a basic battery holder that lets me store batteries once they're charged. So now I can put another battery on the charger, and this guy is ready to go. There are multiple examples of these on Etsy, ranging from about $7.26 here to $9.66. And so we're going to go with the sale price of $8 and base all of our calculations off that. We're also going to do all of these in Canadian, but they do translate pretty well to US dollars. I was able to hop into Fusion 360 and model this in about 20-30 minutes. If you don't have any modeling skills, you'll have to pay someone to do this, and so you'll have to factor that into your total costs and spread that across the profits that you're going to make. CAD design time can be between 50 to $100 an hour, so keep that in mind when you're doing your calculations. So we've hopped into Bambu Studio and we're going to slice this part. And it's going to give us a cost for the filament used, and here it's 0.81 or 81 cents. And that's not quite accurate at this point because the price is a default price that they have set in the filament parameters, which you can find over here on the left. And so the default is $24.99. I believe that's the default US price, and the default Canadian price is actually $29.99. But if you order these in bulk, you get $6 off, so you end up at $23.99. So that's what we're going to calculate here, is at $23.99. And we'll reslice that plate. And we end up at 78 cents instead of 81 cents. So there's 3 cents off that part. From here, we can keep looking at some of the other costs associated with making this part. So let's take a look at the cost of electricity for the printer running this print. For some context, a 100 watt light bulb is consuming 100 watts or 0.1 kilowatts, and the unit of measure for energy is kilowatt hours. So you have to take that power consumption and multiply it by the number of hours that it's running. And so we can multiply it by any number of these hours, 1 through 10. So 0.1 times 1 is 0.1, 0.1 times 2 is 0.2, and so on. And we go from 0.1 up to 1. So if we run a 100 watt light bulb for 10 hours, we end up consuming 1 kilowatt hour. And this is how the power grid charges you for electricity. And so that gives us some context going into the next sheet. So I've looked up a couple of graphs of people who have put a power meter on their printers, and they kind of hover around 60 watts once they're at steady state, but they do have a peak at the beginning when they're heating up. And so I'm going to just use 100 watts as my consumption of power during a print, just to account for some of that surge at the beginning. But you'll see that this kind of all comes out in the wash, and it's not a huge deal how accurate we are here. We just need to use a number for reference. So printer power consumption, we're going to go with 100 watts is 0.1 kilowatts. And then we have print time in hours. And so it was 1 hour and 40 something minutes. And you can see the calculation here. It's 1 plus 41 minutes divided by 60 to give us the decimal version of the hours. So we have 1.68 hours of print time. And then the power consumed in kilowatt hours is going to be our 0.1 kilowatts times the print hours to give 0.17 kilowatt hours. So this is the energy consumed during that print. Now we have a cost of electricity. This is going to vary from region to region. Currently, what I'm paying is 7.49 cents per kilowatt hour. And so now this becomes a pretty simple calculation of 0.17, which is the kilowatt hours consumed, times our rate for the electricity, the 7.49, and I'll hit enter here. And so we're actually at 1.26 cents per part in energy consumed. And if we want to see that in dollars, we can just go here and we can divide it by 100. And that gives you the reference of it's a penny. You're a penny and a quarter of a penny in energy. So very marginal cost for the actual power consumed, but we should still include this in our calculation. You need a way to ship this part to the customer. And for me, a 5x5x5 box is pretty convenient here. And these are going to be 91 cents a piece. There are economies of scale where if you go to 100 or 250, 500, and so on, this can be as low as 63 cents. But for our calculations, we're only going to do a short run where we buy 25 of these boxes at 91 cents a piece. All of the comparable listings that I compared these to did not include shipping, so the shipping was put on the customer, and so we're also going to make our calculations based on that assumption. So we're going to pay for the box itself, but we won't pay for the shipping fees to get it to the customer. Last consideration we need to make is the Etsy fees themselves. So when you type in a sale price here for what you're going to sell, Etsy is going to estimate the fees that will come with that sale. For $8, you're looking at an estimated fee of $1.21, which gives you $6.79 to play with for the room for profit. So we'll add that to our table and see what everything looks like. So now that we have all of the costs associated with creating this part, we have the filament, which is going to cost 78 cents. We have electricity, which is a penny. We have Etsy fees that are 121. We have a box that's 91 cents. And then we have a sale price of $8. We can add all of these up. To give us our final profit. And so we're going to profit $5.09 for every single sale that we make on one of these parts. And so let's take a look at how many of these you need to sell to make back the money that you spent on each of your printers in the Bambu Labs printer lineup. And so we can do that easily over here. If we take these and divide them by our profit, we don't want that cell to change, and it will autofill for us, and we can make these whole numbers because we're not going to sell a fraction of a part. And so if you look at this table now, for an A1 Mini, you would have to sell 49 of these battery holders in order to make back the cost of your printer. The A1 is 86, the P1S is 149, and the X1 Carbon is 305. So that's a lot of these parts that you have to put out the door in order to make back the money that you spent on your printer. And then one of the final considerations that we're not thinking about in this table is wear and tear on your printer. You're going to have parts that are going to fail and you'll have to replace them. So also keep that in mind if this is a consideration that you're having. The easiest way to make these numbers more attractive is to sell a part that you can sell for more money. If you go look at a Print Farm Academy, I believe it is, he has a part that he can sell for $50 because it's a specialized part. It took a lot of time to develop and it takes a little bit more hardware and parts to put together, but it costs him about $4 to create and he gets to sell it for $50. And so if we change that here, we get $47 in profit. And now you're only having to sell 5 of these to make back the A1 Mini, 9 for the A1, 16 for the P1S, and 33 for the X1 Carbon. So if you can find a part that's specialized and not many people can create it or no one else is creating it, then you can charge more money for it and make more money faster and pay off your printer. We also haven't talked about taxes, which depending on where you are could be between a half and a third of your profit gone right off the top. So keep that in mind while you're doing this also. So I hope you like that one, and I'll see you in the next one.